Welcome to the Public Exam Review for Unit 9, Chapter 11, dealing with permutations, combinations, and the binomial theorem. In this presentation, we will primarily focus on using factorials. Here we will focus on simplifying expressions involving factorial notation, as well as using factorials to solve equations that involve n permute r notation. Recall that a factorial is an abbreviation for the product of successive positive natural numbers, where n factorial is equal to n multiplied by n minus 1, multiplied by n minus 2, multiplied by n minus 3, and so on until you get to 3 times 2 times 1, where n belongs to the set of natural numbers. It is also of critical importance that we remember that 1 factorial is equal to 1 and 0 factorial is equal to 1. In this example, we will simplify 3 factorial times n plus 1 factorial, all divided by 2 factorial multiplied by n minus 2 factorial. That then will equal 3 factorial can be written as 3 times 2 factorial. And we will stop there because of the 2 factorial in the denominator. So that will all be divided by, and we will have 2 factorial in the denominator, which will cancel with the 2 factorial in the numerator. n plus 1 factorial is the same as n plus 1 multiplied by n multiplied by n minus 1 multiplied by n minus 2 factorial. And again, we will stop there because of the n minus 2 factorial that already exists in the denominator. Notice now that the 2 factorials will cancel, the n minus 2 factorials will cancel, and we are left with 3n multiplied by n plus 1 multiplied by n minus 1. When you multiply that out, you will get 3n squared plus 3n multiplied by n minus 1, and you can use the FOIL method to multiply that out to get 3n cubed minus 3n squared plus 3n squared minus 3n. This simplifies to equal 3n cubed minus 3n. So that's one way in which we can simplify factorials using factorial notation. Let's look at several examples. Here we are asked to simplify n plus 2 multiplied by n plus 1 multiplied by n factorial. Notice that these values here, these factors, are decreasing by 1. So you go from n plus 2, subtract 1, you get n plus 1. Subtract 1 and you get n. So that can be simplified as n plus 2 factorial. So the correct answer for this multiple choice item is D. Let's just check our answer. Notice that if we have n plus 2 factorial, that is equal to n plus 2 subtract 1, and then you have n plus 2 subtract 1 and subtract 1 again if you want to look at it that way. So in this case here, and that would be a factorial. So this would be n plus 2 multiplied by n plus 1 multiplied by n factorial. So that means that the n plus 2 factorial is a way in which we can simplify the original expression. In example 2, we have to simplify n minus 4 factorial divided by n minus 2 factorial. This time, if we subtract 1 in each case, we would go from n minus 4 multiplied by n minus 5 multiplied by n minus 6 factorial. Notice that it's easier here to keep the numerator the same as n minus 4 factorial, and we will change the n minus 2 factorial to be n minus 2 times n minus 3 times n minus 4 factorial. And we can stop there so that the n minus 4 factorials will cancel. And then what we're left with is 1 over n minus 2 times n minus 3. And that can be simplified as n squared minus 3n minus 2n plus 6 if we're using the FOIL method. And that then simplifies to equal 1 over n squared minus 5n plus 6 as our final answer. Let's look at another example. In example 3, how may n plus 1 times n minus 1 times n minus 2 times n minus 3 divided by 4 times 2 times 3 times 1, how may that be written in factorial notation? Well, let's look at the numerator. We are going in descending, we are subtracting 1 as we go from one term to the other. So if we had n plus 1 multiplied by n times n minus 1 times n minus 2 times n minus 3, if we multiply that numerator by n minus 4 factorial, we would have to do the same thing with the denominator. So if we multiply the denominator by n minus 4 factorial, we would have, I'm just going to rearrange the terms here, 4 times 2 times 3 times 1 is the same as 4 times 3 times 2 times 1. But we will multiply that by n minus 4 factorial again. So you can see now that the numerator can be written as n plus 1 factorial. So we have n plus 1 factorial divided by 4 times 3 times 2 times 1 is equal to 4 factorial multiplied by n minus 4 factorial. And this answer corresponds with D as the multiple choice item. So let's just check our answer to make sure. Here we have n plus 1 factorial, which is equal to n plus 1 times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. That will cancel with the n minus 4 factorial in the denominator. And you are left with what you started with, n plus 1 times n minus 1, n minus 2 times n minus 3, all divided by 4 factorial. In example 4, we have to solve for n, where we have n permute 3 is equal to 60. Recall from our work with permutations that when we have n permute r, it equals n factorial divided by n minus r factorial, where n belongs to the set of natural numbers. This formula will be provided on your public exam. But it is important to remember the restrictions here on the values of n and r. N has to be greater than or equal to r, and both of them have to be greater than or equal to 0. So therefore, we will change the left-hand side of this equation to factorial notation, where we have n factorial divided by n minus 3 factorial to equal 60. N factorial can be written as n times n minus 1 times n minus 2 times n minus 3 factorial. And we stop there so that the n minus 3 factorials will cancel. And that's equal to 60. So we will cancel the n minus 3 factorials, and then what we're left with is n times n minus 1 times n minus 2 is equal to 60. So we're looking for the product of 3 numbers that will equal 60. At this time, I would like you to note the restriction on the domain. So when you look at n permute 3, you must know that n has to be greater than or equal to 3. It's important to recognize that restriction. So now we can use systematic trial and error. If we choose n to equal 3, then we will have 3 times 3 minus 2 will be 2. 3 minus 2 will be 1. So you have 3 times 2 times 1 equals 6. So that's not equal to 60. Therefore, n equals 3 is not the solution. Next, we will try n equals 4. So you have 4. 4 minus 1 is 3, and 4 minus 2 is 2. The product of 4 times 3 times 2 is equal to 24. Again, the answer is not equal to 60. So then we could try n equals 5. You would have 5 times 4 times 3. 5 times 4 is 20, times 3 is equal to 60. Therefore, we know that n must equal 5. Let's look at example 5. Here we are again asked to solve for n, and we have n minus 1 permute 2 is equal to 12. Again, it's important to recognize the restriction on the variables. We know that n minus 1 must be greater than or equal to 2. Therefore, n has to be greater than or equal to 2 plus 1. N has to be greater than or equal to 3. It is important to remember this as we solve for n. So let's change n minus 1 permute 2 to factorial notation, where we will have n minus 1 factorial divided by n minus 1 minus 2 factorial to equal 12. So that simplifies to be n minus 1 factorial divided by n minus 3 factorial to equal 12. N minus 1 factorial can be written as n minus 1 times n minus 2 times n minus 3 factorial. And we will stop there so that that will cancel with the n minus 3 factorial in the denominator. So when we cancel that, we are left with n minus 1 times n minus 2 is equal to 12. In this case, we can multiply using the FOIL method to get n squared minus 3n plus 2 is equal to 12. Bring all terms to one side, and we have n squared minus 3n plus 2 minus 12 is equal to 0. Therefore, n squared minus 3n minus 10 equals 0, and that can be factored. It can be factored as n minus 5 multiplied by n plus 2 to equal 0. N minus 5 equals 0 when n is equal to 5. N plus 2 is equal to 0 when n is equal to a negative 2. Recalling our restriction on the variable n causes us to reject n equals a negative 2. So the only solution in this example is n equals 5. In example 6, we are asked to solve for n, where we have n plus 4 permute 3 is equal to 120. So let's change the left-hand side to factorial notation, where we have n plus 4 factorial divided by, that's the same as n plus 4 minus 3 factorial to equal 120. Simplifying, we have n plus 4 factorial divided by n plus 1 factorial to equal 120. When you multiply that out, n plus 4 factorial is the same as n plus 4 times n plus 3 times n plus 2 times n plus 1 factorial. And we'll stop there so that the n plus 1 factorials will cancel. That is all equal to 120. So when we cancel the n plus 1 factorials, we are left with n plus 4 multiplied by n plus 3 times n plus 2 to equal 120. Again, let's look at the restriction that must exist for the variable shown. So we know that n plus 4 has to be greater than or equal to 3. So that means n has to be greater than or equal to 3 minus 4. N has to be greater than or equal to a negative 1. So again, we can use these values. If I begin with n equals a negative 1, then I'm looking for the product of 3 numbers, 3 consecutive numbers that have a product of 120. So we have negative 1 plus 4 will be 3. Negative 1 plus 3 is 2. And negative 1 plus 2 is 1. The product of these 3 numbers is 6. So then we go with n equals 0. 0 plus 4 is 4. 0 plus 3 is 3. 0 plus 2 is 2. 4 times 3 is 12, times 2 is 24. The product is not equal to 120. So then we go to n equals 1. 1 plus 4 is 5. 1 plus 3 is 4. 1 plus 2 is 3. 5 times 4 times 3 is equal to 60. If we try n equals 2, 2 plus 4 is 6. 2 plus 3 is 5. Times 2 plus 2, which is 4. 6 times 5 is 30. Times 4 is equal to 120. Therefore, we know that the value of n has to equal 2 in this example. There are other ways in which you could solve these equations. I'm just choosing what I think is the easiest way to solve them. If you multiplied all these factors out and you brought the 120 to the left-hand side, you could also use the integral zeros theorem to solve this equation. I just think that this is the easiest method that you could use. Let's look at example 7. Here we have to solve for r. So we have 5 permute r is equal to 5 factorial. This one can be a little bit tricky, but again, it is important to note that 5 must be greater than or equal to r, which must be greater than or equal to 0. So that tells us then that that the value of r is going to be less than 5, but greater than or equal to 0. So if we look at this example and we change the left-hand side to factorial notation, we will have 5 factorial divided by 5 minus r factorial to equal 5 factorial. When we cross multiply, you have 5 factorial times 5 minus r factorial equals 5 factorial. So now what we're going to do is to divide both sides of the equation by 5 factorial. We could do this because there are no variables in the denominator. So 5 factorial over 5 factorial leaves us with 5 minus r factorial equal to 1. At this point, it is important to remember what factorials actually equal to 1. You have to remember that 1 factorial is equal to 1, and we also need to remember that 0 factorial is equal to 1. It is critical that you remember this at this point in time, because now we know that if 5 minus r factorial is equal to 1 factorial, then we know that 5 minus r must equal 1. So a minus r is equal to 1 minus 5, minus r is equal to a negative 4, and one value of r is equal to a positive 4. Note in the other case that if 5 minus r factorial is equal to 0 factorial, then we know that 5 minus r must equal 0. So a minus r is equal to 0 minus 5. A negative r is equal to a negative 5. So another possible answer is r equals 5. So in this example, we have 2 possible answers for r. And notice that in both cases, if r is equal to 4, that 5 is greater than or equal to 4, And we also know that when r is equal to 5, that 5 is equal to 5. So both of these are acceptable solutions for this example. In example 8, we are asked to simplify. We have 6 factorial multiplied by n plus 1 permute n minus 1, all divided by 3 factorial. So let's use factorial notation to represent the permutation. 6 factorial, by the way, is equal to 6 times 5 times 4 times 3 factorial. And we'll stop there so that that will cancel with the 3 factorial in the denominator. In the meantime, we also have n plus 2 factorial divided by, that will be the same as n plus 2 minus n minus 1. And all of that will be a factorial. And of course, all of that has to be divided by 3 factorial. Notice, first of all, that the 3 factorials will cancel. So that makes life a little easier. So then we have 6 times 5 is 30, times 4 is 120, multiplied by n plus 2 factorial. And all of that will be divided by, now we need to check the brackets. So that will be the same as n plus 2 minus n plus 1 factorial. Continuing to simplify, we have 120 times n plus 2 factorial divided by, notice that n minus n will cancel, and you're just left with 3 factorial in the denominator. 120, that can be further simplified as 120 times n plus 2 factorial divided by 3 factorial, which is 3 times 2 times 1. 120 divided by 6 is equal to 20, multiplied by n plus 2 factorial. So this one is now simplified as far as it possibly can be. As a summary then, a factorial is an abbreviation for the product of successive positive natural numbers. N factorial is equal to n times n minus 1 times n minus 2 times n minus 3, and so on till we get to 3 times 2 times 1, where n belongs to the set of natural numbers. It is also important to remember that 0 factorial is equal to 1. As well, when we're using permutations, if we have n permute r, it is important, well, the formula will be provided for us, but it is important to note that n has to be greater than or equal to r, and both of them have to be greater than or equal to 0. That restriction on those variables is important to note. And the reason the restriction exists as it is there is because if you have to select r objects from a set of n objects, you can't select 2 objects, for example, from a set of 1 object. Or you can't select 5 objects from a set of 3 objects. And when you consider the number of ways in which if you have a set of 5 objects and you have to permute 0, there is only one way to select a set of 0 objects from a set of 5 objects, and that is not to select any. So that is the reason why when you have 5 permute 0, the answer will equal 1. Thank you for your time and your attention. Good luck as you continue with your review.